Good evening. Given that we didn't have a lot of time to spend on truth tables and we didn't have the opportunity to go through some of the nuances that I would have liked to have covered in recitation, I'm going to make a few supplemental videos that go through and walk through some of the elements of truth tables and also try to unpack why certain operators work the way that they do with respect to truth value, why it is that we can think of ands as being true only when both sides are true, why disjunction only has to have one side be true, etc. Before we get into truth tables, though, I want to start a little bit further back. I want to start with truth values and make sure that we're all on the same page. In doing so, I'm going to be using non-truth table examples, but then we're going to transition into truth table examples. In one of the later videos, I'll go through a few different examples of actual truth tables. I'll pull in some examples where we're analyzing a propositional statement with respect to whether it's a contingency, tautologous, or inconsistent. And then in the third video, I'll go through and I'll do a few examples of how to do a truth table to analyze an argument with respect to validity and invalidity, and also how to do a shortcut truth table. But let's start with this one instead. So today, let's go ahead and just start with truth values. When we think about truth values, there's two things that we can say. Namely, either something is or it isn't. You can also think of this as the law of the excluded middle, but if you're not quite sure what that is, that's okay. By saying that something is or it isn't, let's just translate that as something is either T, as in true, or F, as in false. Now, when we say that something either is true or false, it might be helpful to have an example of what that something is. So let's use a toy example. Let's say that we have a person. Let's call them Sam. And I'm just going to have a few additional components here just so we can make some sentences. Let's say that I tell you the following. Sam has a dog. So I walk up to you in the middle of class and I say, hey, here's a fun fact. Sam has a dog. That statement, that proposition, the proposition that Sam has a dog, has a truth value. Either it is true that Sam has a dog, or it is false that Sam has a dog. Let's say I did the same thing to a different person in class. I walked up to them and I said, Sam has a penguin. Much like this proposition, Sam has a dog, the proposition that Sam has a penguin is either going to be true or it's going to be false. When we think about sentences of this sort, propositions, claims about the world, we tend to say that these sentences either reflect a truth in the world or they're not quite accurate. The statement Sam has a dog is either true or false. The statement Sam has a penguin right now, currently, is either true and false. For the most part, it tends to be the case that folks understand what's happening when we're talking about single sentences of this sort. Let's talk about slightly more complex sentences. So let's say that rather than just making these simple, let's call them atomic sentences, let's say that I gave you a sentence like this. Sam has a dog and a penguin. Much like our first two sentences, this sentence is either going to be true or it's going to be false. Either it is true that Sam has both a dog and a penguin, or it is false that Sam has both a dog and a penguin. So it too will have a truth value. Notice that this is slightly more complex, however, because there's a conjunction in there. There's an and. We're making a claim that is a slightly more complex claim than the simple claim earlier of Sam having one specific object or one specific pet. Here we're saying that there's two objects, two pets that Sam has. But overall, this statement still is going to have a truth value of true or false. Let's figure out what would happen if I said this instead. Sam has a dog, or Sam has a penguin. And I could also leave out the Sam has. Like I could leave that part out and the sentence would still make sense. This sentence too has a truth value. It's either going to be true that Sam has a dog or Sam has a penguin, or it's going to be false that Sam has a dog or has a penguin. Much like the other sentence, this one's slightly more complex because we have, again, two things that are going on. We're saying that not just a simple claim that Sam has a penguin is true or false. we have an operator there, we have an OR, and we're going to see when we get to the actual truth tables how we diagram an OR, but I want folks to think about this as a real example. Let's do 2 more, just so we can have an idea. Let's take the claim, if it is a, and let's go like if it's a duck. If it is a duck, it is a bird. While this is a slightly different type of sentence, namely this is a conditional sentence, like all the other sentences that we've seen so far, it's making a certain type of claim about the world. And in making a claim about the world, it is either going to be true that if something is a duck, it is a bird, or it will be false that if it is a duck, it is a bird. Now, as with all 3 of these things so far, it might be the case that these things are true some of the time and false at other points. So let's say that right now Sam currently works at a zoo and is allowed to own the animals there and happens to own both a dog and a penguin. 10 years down the road, Sam no longer works at the zoo, no longer technically owns a penguin. So right now the proposition that Sam has a dog and a penguin might be true. A few years down the road, it might be false. We're going to talk about that as well when we get to elements of truth tables and contingency, but that's just something to flag now. Nothing that I've said so far says that universally these propositions, these sentences, can only ever be true or only ever be false. Some of them might be true some of the time, and they might be false some of the other time, and that's okay. So let's go ahead and move to truth tables and actually start looking at truth tables. What we're going to do is we're going to take sentences like this, Sam has a dog, and we're going to simplify them down. Instead of saying the entire sentence, Sam has a dog, let's call the claim, Sam has a dog, A. Let's call the claim that Sam has a penguin, B. And let's go ahead and start making truth tables to try to unpack how we can understand using the logical system we're in, what exactly that means. So let's draw a truth table. Let's start with a single sentence, or in this case, a single atomic thing. Let's say that I tell you, Sam has a dog. If we want to analyze this claim that Sam has a dog, we want to know what kind of truth values it could possibly have. So what we do is we draw this. This is a basic truth table. It's a truth table that is for one single letter. And on the left side of our truth table, we have what we might call a key. The key, once we get more than one letter going, is going to tell us about all the possible combinations and permutations of true and false values for multiple letters. In this case, given that it's just an A, what we do is we just write A here, and we write as many letters as we have here as we have over on this side. Since we just have one single letter there, we just write one type of letter here. And then we assign all the possible truth values for A here. A can either be true or false. And then we copy and bring these all over and put them under any instances of A. In this case, there's only one. So we just write down T and F. This is how we account for single atomic letters for a truth table. It's going to look like something like this. That said, as we saw earlier in some of the logical things, we do have modifiers. We have operators. One of the operators that sometimes we run into is an and. So or not an and, is a negation. So let's see what a negated truth table looks like. So let's still stick with A. And remember, A is the claim that Sam has a dog. Let's say that I told you it is not the case that Sam has a dog. What we do first to set up our truth table is we start by drawing the truth table and bringing as many letters as we have over here, in this case there's just one, over to the left side. And then we write one T and one F. And then as before, we bring these values and we bring them over and slot them in under every instance of that letter in our statement, or when we get down later in our argument. So we put a T here and we put an F here. Now, we have a negation. So what negations do for truth tables is they flip the value. So a negated T becomes an F, and a negated F becomes a T. Now, when we read these columns, and we're going to do this after I introduce the first 5 tables, we only read the main columns. The main columns are the last column that you end up filling out. And we're going to work through how to figure out how to fill out those columns. But in this case, the main column would be this column right here. And for this one, it's the column right there. So let's look at more complex truth tables. Let's go back and say, remember, A is Sam has a dog, B is Sam has a penguin. And let's say that I told you that it's the case that Sam has a dog and Sam has a penguin. Now, remember what I said earlier. Over on this side, we write as many letters as we have over here. In this case, instead of having a single letter this time, we find that we have 2 letters. Since we have 2 letters, we're going to have 2 different columns on this side in order to represent each letter. When you're writing down more than one letter, put the first letter that occurs on this side. That's the first letter. Put that first. And then put the second letter second. This is just to make sure that your truth tables are going to make sense when the TAs are looking at them. And then for the pattern's slightly different. As I said earlier, this key column over here, in this case, these key columns, is to figure out how many different possible combinations there are of true and false values. So in this case, if we were to look at all possible worlds in which I look at the statement, Sam has a dog and a penguin, we want to see how many different possible combinations are there of those worlds. How is it possible for there to be a world where Sam has a dog and Sam has a penguin, where Sam has one but not the other, where Sam doesn't have either of them? And to figure out all those possible combinations, we use the following pattern. For 2-letter truth tables, you write 2 T's and 2 F's. And then for the base column, this is called the base column, you alternate T's and F's. So just like you did originally for the 1-letter truth table, we alternate T's and F's. And what this does is this tells us that if we have independent truth values for A and independent truth values for B, there's going to be 4 different ways that those things can interact with one another. Namely, they can both be true, one can be true, or they could both be false. Now let's fill out the truth table. So what we're going to do is we're going to take all these values and we're going to slot them into our main thing over here underneath the letter that is over here. So for the A, we write down everything we had in that A key column. For the B, we do the same thing. And now we have to figure out the main operator. In this case, the AND is the main operator. This is the column that we're going to want to look at when we're assessing whether or not this is contingent, tautologous, and consistent. But before we get to that, let's just learn to fill it out. So for an AND statement, in order for an AND statement to be true, both of the independent pieces have to be true. So let's go back to think about our case when